Hi there, and thank you for inviting me to speak here at DevOps Stage 2022. Today we're going to be talking all about end-to-end inner sourcing and secure development with GitHub. Now, I'm sure many of you will know GitHub already because of open source, probably a large percentage of you actually. So perhaps you're using GitHub because you are using some open source components in your project. Maybe you even contributed to your favorite open source project, or maybe you maintain a project, in which case, thank you for your contributions to the developer community. But today we're going to be talking all about open source and how we can bring those practices and those principles to the work that we do within our organizations every day. So my name is Chris Reddington. I'm a senior enterprise advocate at GitHub, and I work with startups, small businesses and enterprises, helping them use the best aspects of GitHub and make sure they're using all of those great things that we have learned from the open source community. Now let's start there, because actually GitHub as a platform is pretty phenomenal. The numbers on the screen here speak for themselves. Over 83 million developers use the platform, over 4 million organizations, and that translates into 2.6 billion contributions per year. So across organizations that are using it for their day-to-day or the open source community, we have a lot of knowledge that we can build upon and share in terms of those modern engineering practices that you may be able to adopt. Now, I mentioned enterprises, businesses, startups, etc., and of course the open source community. Now you can see a few logos on screen here that you may recognize, but ultimately the point that I want you to get thinking about here on this slide is the various open source communities that are using GitHub in their day-to-day. Take, for example, Kubernetes. Kubernetes was one of the logos on the screen. There are many others like React, Angular, Vue, Hugo and others, but a lot of software projects run and maintain themselves on GitHub. So that goes from the planning stages, the roadmaps, communicating what you want to do with the wider developer community across the world. Because think about it, those folks that are involved in the development of those projects and the engineering of those projects are a distributed team. They're distributed globally. They don't have the chance to come together regularly and meet in person and talk about the direction of the project. Some projects may be able to do that. Some may meet virtually, for example. But we've got to work in a slightly different way. We've got to be inclusive. We've got to make sure we're communicating standards effectively and making it easy for anyone to contribute into our project. Now, if you actually want to get started with GitHub and with contributing into open source, it's a really great place to go and start. And there's several reasons actually why you might want to go and just create an account on GitHub if you haven't already. When I usually do this kind of talk, I do a show of hands here, and the majority of the room normally holds their hand up to say they've got a GitHub account and they've got pet projects or they're contributing to open source in some way. But actually, as an individual user, you get a load of benefits just by having a GitHub account. For example, you can have an unlimited number of public and private repositories, so you can host your code on GitHub for free. Now, of course, security is a big focus for all of us these days, and it's something we'll talk about a little bit later as well. But again, that's something that you can get for free for open source projects, for any projects that you have publicly available at those repositories out in the open. And what we can do is we can use something called Dependabot to be able to keep up to date all of the dependencies and the versions that we might be using in our code base. Again, something we will look at a little bit later. And finally, GitHub Actions. With GitHub Actions, with a GitHub repository, for your private repositories, you get up to 2,000 minutes for free of usage of the platform. But for any projects that are open source and the repositories are publicly available, those are completely free. So actually, GitHub really embraces open source and loves open source. So if you want to get started, either contributing to your favorite projects, or even maybe starting your own pet project or creating a brand new open source project yourself, the place to start is github.co/signup. And I promise that is not a typo. That's just an easy link for you to get to our sign up page there. Now, of course, open source is one part of the puzzle there. We use open source in our internal projects. We use open source in our day-to-day. And some of us will even contribute into open source as well. But we also need to think about the day-to-day development when we're working within our organizations, whether we're a startup, a small, medium business, an enterprise. We need to think about how we are empowering our software engineering teams to do their best work. Now, it's well known these days that actually DevOps principles and DevOps practices are so pivotal to accelerating our velocity, to getting more frequent code deployments, faster commits to deployment lead times, for example. And ultimately, this world that we're now building in is cloud-based. And one of those ideas from a cloud engineering perspective is we don't say if something is going to fail, but when it's going to fail. So making sure that we are embracing automation, bringing those teams together to make sure there's no silos, so we have that overall view, we can make sure that we can reduce that time for recovery, because inevitably there's going to be a failure at some point, and we need everyone to be on the same page. We need everyone to understand their roles and their responsibilities and be effective in those particular situations. Now, this data actually comes from the recent Google State of DevOps report. Encourage you to go and check out some of those industry reports so that you can find out a little bit more about how this tooling and this functionality can help you when you start adopting these modern engineering practices. Now, DevOps is one aspect, but actually there's a big elephant in the room these days, and that is security. Again, this is normally where I do a show of hands during one of these talks, but who here has maybe been a part of a project? You get towards production and you're about to deploy maybe in a couple of weeks' time, and you say, right, we should probably go and get security to go and sign off on this. Only to find out that security have found maybe some vulnerabilities, some dependencies that you shouldn't be using, or something that breaks the rules. That inevitably delays the project, it delays the launch, everyone gets frustrated, developers are frustrated with security, security frustrated with developers. We're building more silos there because we're not bringing them along that development journey, really embedding security into our developer lifecycle. Now, this is really important because actually these days the applications that we write, 80 to 90% of them contain open source. Now think about that. When was the last time you wrote a logging provider or an identity provider or one of those modules, those different packages, let's say, that you just built on top of the work of someone else? And open source is something not to be feared within our organizations. It's something we should embrace because as a developer, it makes me more productive. I don't have to reinvent the wheel anymore. I can go ahead and write the code and write the products and the functionality that is really important to my end users, rather than having to, let's say, write the plumbing underneath, for example. But of course, in a time where vulnerabilities because of those open source packages is a big risk, who here maybe had to get involved in some Log4j events, for example? You know, that was a big wake-up call for the industry. So actually, what we need to be thinking about is how we can embrace open source in a secure way and make sure that we are using that in a way that our organization is aware of the risks that we're bringing in. Now, today, organizations are working in silos. We might have a team which is working on one application, a team working on another application. Maybe If we're a retailer, we have a shopping cart team, a catalog team, a user team, for example, whatever they may be. And then perhaps we have a central team that builds, let's say they have shared templates, libraries, different components that ultimately empower the application teams to be productive, to follow guardrails, to follow that paved path, if you like. But the problem is if we start having a way that we're kind of very issue-based or ticket-based and trying to get those teams to work together, we can start building those silos, because application team 1, that's shopping cart team, let's say, might need something from the catalog team. Both of those teams might need something from the shared Center of Excellence team. And the challenge is, when we've got all of these dependencies, if we're not allowing those teams to effectively collaborate and contribute into each other's work, we're building silos, we're building friction. In the shared Center of Excellence team, they may not have the same priorities that the application teams do. An application team that is focused on the shopping cart might be really focused on some new payment standards, for example, that are coming out, which are critical and might have some compliance reasons against them. But actually, the catalog team don't care about that at all, and they need something from the shared Center of Excellence team. And you can see the challenges here. There's lots of dependencies, there's mixed priorities, so there's inevitably going to be some conflict along the way at some point. But this is where inner source comes in, embracing those practices from the open source community about working out in the open and allowing individuals to contribute directly into the other code bases. Now, this sounds like a really scary thought, because I've wrote my share of code. I wouldn't necessarily say I'm the best developer, but I don't want other people seeing my code, especially outside of my team and across the organization. They'll probably judge me for the type of code that I'm writing and the standards that I'm writing as well. And that's a natural feeling. We get quite defensive about what we've written and protective about what we've built. But actually, if we can lower those barriers and allow those teams to contribute into each other's work, we're getting rid of that friction between those teams. We're improving that overall developer experience. And this is something as GitHub that we care deeply about. So adopt those open source best practices internally, thinking about, for example, defaulting to open, having your repositories accessible to everyone inside your organization. So the ability to be able to fork a repository, propose some changes, and then the team that owns that repository decides whether it's relevant. You know, should we include that and maintain that as aspects of our code base moving forward or not? And if it's not suitable in the current format and the current context, maybe they can collaborate on a pull request and make sure that the contributions are appropriate. Just because I message you or create an issue for you doesn't mean you have to instantly respond to that in a synchronous way. Asynchronous programming is something many of us are used to, but asynchronous working is something we can definitely get better at. Being able to leave that work for someone to complete and expect that an instant response and instant reply is not what we're going to get, because those folks will have other priorities which are important to them. And ultimately, it shouldn't be issue-based and ticket-based. If I can see something in that shared repository, that central repository that I need for my application team, I should feel empowered to be able to go and contribute directly into that by using a pull request. The host team then owns that, they review that, they propose some changes to me or let me know that it's not appropriate for whatever reason, and we can go from there. But ultimately, we should be empowered to work more collaboratively together internally. And all of this stems from what we know from open source communities. Now, of course, we start typically within GitHub with a repository. We have issues within our repository, we have project boards, etc., that we can go and visualize the plan. So let's assume for the sake of time today that we have our plan in place and we need to start coding. Now, in a world where we're trying to bring down those silos, we live in a world where actually we have microservices, we have different languages, different frameworks. I'm not guaranteed to have the latest Golang version on my machine, or the Java binaries, or whichever framework that I need to build another project within my organization. So if we are embracing those open source principles by defaulting to open, we're reducing those barriers, that's going to mean that I need to have my development environment set up in a way that I can be productive with whichever team that I'm working on. Now, with that breaking down of barriers becomes developer satisfaction, because actually we're enabling that collaboration, we're enabling teams to work more effectively together. But who's ever had that challenge where it works on my machine? You know, I've joined a new team, maybe I've just been recruited into an organization, for example. The first thing I have to do is get my laptop set up with the IDE that I need to use, the frameworks, the tooling, etc. And if I'm lucky, maybe a few hours later, I'll get the environment working. If I'm unlucky, maybe days or in some cases weeks, that environment does not work still, and I haven't been able to get my first build going. It's frustrating. It's incredibly time inefficient, and it's not something that we have to put up with as developers. And this is where GitHub Codespaces comes in. And GitHub Codespaces helps us reduce that time to development productivity from days or weeks to minutes and seconds. So we're going to go ahead and take a look at a project here that I have, a bookstore that I'm making, in fact. So we can see here that I have a GitHub repository just like any other repository that we would be used to seeing publicly. We can see it's private, so it's internal within my organization. And I can see that we're following best practices, for example, like having a README. So documenting specifically what the purpose is of that repository, so that if anyone in my organization is taking a look through, they can understand that this is a Maven project, it builds into a standalone jar file, and they can see that it's to do with a bookstore. There's a nice screenshot there showing what this is as well. We then also include some information about how to contribute and other information to lower that barrier of entry for other developers inside my organization. Now, I mentioned a moment ago about GitHub Codespaces and the ability to get started really quickly. So we're used in GitHub to using this green code button and cloning locally to my machine, opening up something like Visual Studio Code, Visual Studio, or your favorite IDE, and then going and installing the frameworks, the dependencies, everything that I need to then start building locally and being productive. But it doesn't need to work like that. You can see on the right hand side here that I have this Codespaces tab as well. What I can do is I can click this Create Codespaces on Main button here, and you can see that what's going to happen here is GitHub is creating this new thing, a Codespace in the background here. Codespaces is built using containers. So in the back end, what GitHub is doing is spinning up a container based upon some specification that I have created. So you can see here I've got this folder called .dev container in my repository, and I have two files, a dev container.json and a docker compose YAML file. You could also use a Docker file and a Docker image there as well. In my dev container.json, you can see that this is effectively a cookie cutter or a template of how I want that environment to look. So anytime that someone comes into my repository and creates a new code space, it will be based off that Docker compose file that we just saw. It will open up port 8080 in that environment, and it will make sure that these extensions are available to make sure those users can be productive. Now we can also see again the Docker compose YAML file here specifies which image we will be using there as well. But if I jump back here now over to GitHub Codespaces, you can see that in the time that it's taken me to explain what GitHub Codespaces is, we've built the container and now it's going ahead and connecting to that environment for me. What I'm actually going to do is I'm going to navigate to one that I have already available. So you can see that I'm actually in my web browser here. If I go on the top here, you can see that this is just a URL. This is something that I can access wherever I am on whatever device I'm on. So as an example, if I wanted to take a trip on the bus to go and see some friends and something urgent comes up, it's okay. I've got my iPad on me. I can go ahead, log into Codespaces, make that quick change, and off I go. Crisis averted. Now you can see that this looks and feels like Visual Studio Code as well. So for example, I have access to my extensions that we talked about a bit earlier. We can see all of the installed extensions there as well. I can go and navigate my code, for example, here. And I can even do things like build locally because we have a container. That is a container running on GitHub. So when I say locally, what I mean is locally within that container. So let's call it cloud local. We'll create a new term here. So I can go ahead and just use the commands that I'm used to when I'm running in a Linux terminal. You can see I'm just listing the directory there. But I've actually got a .vs Code folder here with a number of tasks. So I'm just going to go ahead, first move to my main branch. And I'm going to go ahead and run a task, code a new feature, and we're going to create a book star rating feature there. So this is just to help me with the demo a little bit, just something quick and easy here. Now you can see I've created a number of different changes there. So we're adding a rating property, we're initializing that book there, and you can see there's some additional changes that we're making. So I might go and commit that. So initial book store implementation for rating. There we go. And you can see that it's already prompting me. Do I want to publish this branch to GitHub? Yes, I do. And then just behind my camera here, if I just zoom in a little bit, you can see that I can create a pull request right from within Codespaces. So I'm just going to go ahead, keep that as the default. And then when we navigate back to GitHub, we can see there's now 7 pull requests. And in fact, this was just created for us, which is awesome. But you know what? Actually, there's some additional changes that I want to go and make. And I could go and do this using something called GitHub Copilot. GitHub Copilot is your AI paired programmer, and currently it's generally available for individuals, but stay tuned for more news for enterprises coming soon. Now, what I can do is I could go ahead and navigate to one of my services, for example. Let's say I've got this book utils class here, and I've got some get sample books here. I have the GitHub Copilot extension installed. So what GitHub Copilot allows me to do is write some comments, and then Copilot will suggest some code back based upon that. So if I type something like filter books by author method, you can see that in fact, it's now just generated an entire class for me of how to filter books by author. Better yet, let's go to our tests. Let's go to service and let's create a new file called filter by author test.java. We can see that it's been created there in terms of the structure based on the file we created. And I might say something like, let's go and test the filter by author method. And if I go and hit Command and Enter here, you can see that actually it's come up with a number of different options here for me to go and run that test. So without really having to think about the nuts and bolts of what I'm implementing and just using comments, GitHub Copilot has been able to help me accelerate my productivity and get some code written here. Now, of course, it might not give me absolutely everything that I need, but it certainly helps me be more productive and makes a really clean developer experience for me there, which is brilliant. Now, let's think about that development lifecycle, because we've written some features, and at this point, we checked in our book star rating functionality into main. Or rather, we made a pull request to go and put that into main, I should say. We checked it into a separate branch. Now, at this point, we probably want to make sure that we're following some kind of security practices, because as soon as the code gets to main, we should consider that code to be production ready effectively. There are different approaches and principles people follow, but we need to make sure we have some quality gates along the way and shift left quality checks in our development lifecycle. So I want to talk to you about something called Dependabot. Remember what we said a bit earlier about the open source dependencies that we're bringing in to our software projects. We should not be afraid of open source. It's something we should be embracing to help us really focus on our end users and the value that they are looking for from our applications. So rather than reinventing the wheel, let's use those open source frameworks and dependencies which are out there. But we want to use those in a safe and effective way. So for example, Dependabot can help us identify whether there's security issues in some of the packages we're using. It can also help us make sure we're using the latest and greatest dependency versions. So let's go ahead, take a look now at Dependabot in action. So I'm going to go navigate back to the codes tab here of my repository. And you can see that we've got this big kind of amber banner on screen here warning me that there's potentially some security vulnerabilities in my repository. No one wants to see that, of course, that they've got potential security issues. So immediately I'm going to take action on that. And we can see, in fact, that there are several different alerts there and a couple which are high. So I probably want to go down in priority order from the criticality there. So if I just go and take a look at this alert here that has popped up, right from within my repository, I'm getting insights around the version of which dependency is causing issues, the attack vector, the complexity of the attack, a rating, and information overall about what this issue is and how it can be potentially invoked. So I don't have to go to other security tools, other development tools. I'm right within my flow, right within my repository. And Dependabot is great because I can just click this button, and what's going to happen in the background is Dependabot will create a brand new pull request for me to review to go and make sure that we can update those dependencies and mitigate those issues with that particular version. Now, talking about pull requests, you can see in here that actually I've raised a couple of my own pull requests, but there are several dependencies in here as well that Dependabot has in fact created for us. So as an example, this one here is bumping a version of the Azure provider within HashiCorp from 3.11 to 3.21.1. It's not necessarily a security issue, but it's helping me stay on the latest and greatest versions. So if there's new features and functionality, I'll be able to get the best of those there. Better yet, it's in a pull request, so I can see the release notes right there. I can see the commits, for example, as well. And as I scroll down, you can see that we even have checks built in to this pull request view as well. So right within this flow and right within this change, I can see that actually several automation workflows that have been running there have all completed successfully. All checks have passed. So this actually looks pretty good to me. I can now be confident that this change of dependency version does not break the existing code base, the existing builds, etc. And this is why we should rely on automation and automate our builds and our tests, etc. So this looks good to me. So I might come in here, take a look at this, have a look what's changed. Now I might say, you know what, this looks good to me. I'm going to go and approve that. And at this point, it's got the approval. So we can now go ahead, merge those changes into main and be comfortable that we haven't necessarily broken the build, as far as we know, at least. You know, we're depending on the GitHub Actions and the checks here, really checking the quality of the software that we would expect it to be. So again, stresses the importance of automation here. Now, actually, let's talk about GitHub Actions. GitHub Actions is really the automation engine behind GitHub. So it's not just for continuous integration and continuous deployment, but that is a large part of why you probably would use it. There's over 13,000 actions available on our marketplace via our community, and you can use it with numerous operating systems. So whether it's a Mac, Linux or Windows, there are hosted versions available from GitHub as well. And I mentioned CI/CD as one of the main things that you might use it for, but actually think about the open source scenario once again. Think about something like opening an issue and welcoming a contributor, or making sure that, I don't know, once a label has been applied to an issue, some kind of automation has kicked off. Maybe you fire off to an API, or you do some kind of automation to enrich what has just happened there. This is actually how we work internally at GitHub. We have a lot of issue ops, and for example, if we're running certain sessions, we might label an issue and then have something kick off in the background as a result. And think about it from the open source perspective, where maintainers are doing this in their free time. They need to make sure that they are automating as much as they can to focus their productivity on building that best application, that best software for the open source community. So actually, we could go ahead and reuse some of these capabilities internally within our organizations as well. So let's actually take a look at that. So if I go and take a look at GitHub Actions just here, you can see I have a tab, and there's a number of different options that we can use here. So I might take a look at this build, test, publish workflow. And if we just zoom in a bit here, there we go, we can see that we've got this kind of multi-step pipeline which is happening here. So if you've used other DevOps tools, this kind of view will look very similar. I can even go ahead and click on the job here and even see the output from the logs here as well. So all really good there in terms of that insight into what's going on. Now, the way that you author GitHub Actions workflows here is by going to this .github folder, going to workflows, and you can see you have a number of YAML files. Now, I always ask a question here, and I'm just going to give a pause for a moment to let you think about this. What do you notice about the convention of the line that I have selected there on screen? Actions / checkout and a version number. If you said that that is a GitHub repository, then you are absolutely correct. If I go to Actions / checkout, you can see this is just another GitHub repository. And this is what makes GitHub Actions so powerful, is the fact that you can use these other actions which may have been made by open source maintainers or maybe vendors like Microsoft or HashiCorp, for example, and the ability to be able to go and build on others' work. So rather than having to reinvent the wheel. And we can see that if we click on releases, that in fact, we can find the changelog from version 3. So we can actually then start specifying a given version of that repository in time to make sure that we're not, what's the word I'm looking for here? We're being deterministic in the action that we are using. So updating actions shouldn't break our workflows. Now, that's all great. We've got action/checkout here. We've got action/GitHub script there. And if I scroll down even further, you'll notice that actually we can run scripts inline as well. So you can see I'm just doing a Maven run, or sorry, a Maven package there, I should say, to build and test the package. If we go even further down, you'll notice on this line that it kind of looks a little bit like a repository, but not quite. There's a bit more information in there. Like the repository was just the organization name and then the repository name. Whereas we've got this kind of file path or this folder path thing going on here. Well, actually, if I just go to github.com, that repository, and take a look at my workflows and a build and publish container, this is something that we call a reusable workflow. So think about the context at the very beginning. We have that center of excellence team that is building templates, maybe building pipelines and different workflows for the different application teams. And maybe we want to set a standard on how we build Java applications inside our organization. Maybe we build using Maven, we then go and containerize that image, store it in a container registry somewhere, etc., etc. Rather than having each application team define that themselves, wouldn't it be better if we could define this once and reuse this across all of those application teams? And this is exactly what this is doing. We're defining this cookie cutter template once, defining the inputs and the secrets, and then the outputs, and then the jobs that, or the steps I should say, that are then followed. And that is how we actually go and scale these workflow usage across our organization and then start embedding those standards and that consistent way of working. And you can see this is how that inner sourcing idea is starting to come back around here, because we can then go and actually contribute back into that central repository if something doesn't quite fit our needs. Now, of course, it needs to be weighed up against the central team's priorities, whether it breaks functionality for other teams. But we're now getting into this workflow where we are empowering what we can do as an application team and how we partner with other teams there as well. And if we think about something like code scanning is something available as part of GitHub Advanced Security. So if you're using this inside of your enterprise, this is something, an add-on that you'll need to purchase separately. But for an open source repository, an open source project, public code, this is something that you're able to get for free. Now, code scanning is a great aspect of GitHub, because what you can do here is you can go and navigate to your repository, go to the security tab, and again, right built into my repository, I can see all of the alerts that have been brought up from code scanning. I'm right within my flow, I'm right next to where my code is hosted, so I can go and make those changes really quickly. Now, you can integrate code scanning with third-party providers as long as they use the Serif output format. And you can see there's a really easy way to get some workflows configured and set up and started here as I'm scrolling through screen here. Now, the built-in scanning engine within GitHub is something called CodeQL. So imagine if you could take your code base, deconstruct it into a database, and then query over that database for certain patterns. That is exactly what CodeQL is, as the clue is in the name there. If I go to my pull requests and look at one that I raised a little earlier, if we scroll down and find our checks, we can see that actually one of my checks is failing regarding CodeQL. We can see there's one new alert, including one high severity security. So clearly, as part of my pull request, there's a change that I've made that is introducing some kind of issue. And I could even go take a look at the show more details aspect to go and see exactly what is happening there. So I can see what line is the issue, And I can even trace back through the paths of my code to understand how we got to that location and why that's a problem. So in this instance, it's identified a potential SQL injection. And we can write our own queries. There's code packs, or query packs I should say, which enable you to find some of these example different issues that you might come up with, like the OWASP top 10. But we could enrich that and build our own queries as well, which is really powerful. And then finally, the other aspect that I'd love to go and talk to you about here is secret scanning. Who here has ever gone ahead and leaked a secret because you were working on something locally in your dev environment, you have got your feature created and you push the changes up only to realize, I left that secret, I left that password in code. It's now been pushed up to GitHub or whichever provider I'm using, and I've leaked that. I've been there. Plenty of other people I know have been there. It's so easy to make that mistake. Secret scanning is there to help you. Recently with secret scanning, GitHub released something called push protection to ensure that it doesn't reach that main branch. But actually, if there are already secrets in your code base, then it will alert you and it will notify you to take some action there. Now, of course, if the secret is out there, even if our history, it has been leaked. So it's something that we should really make sure we maintain, and we go and rotate that and burn that key. It's not something we want to have anymore. Within open source repositories, again, there is a flavor of this which is free, and there's integration with cloud providers and third-party providers to automatically revoke those keys. For private repositories, again, you need GitHub Advanced Security for that. And there's some enhanced functionality that you can do, like even create your own custom patterns for keys as well. So there we go. We've had a walkthrough of several features within GitHub that can enable you to use some of those open source practices and enrich that experience with the GitHub features and capabilities. We first looked at open source communities and some of the patterns and practices that they use, defaulting to open, using pull requests and lowering those barriers and enabling anyone to contribute. We then looked at how we can code across those different repositories. Maybe I don't have the dependencies on my machine, but that's okay because I can use GitHub code spaces to help me lower that development productivity time. Then what we looked at then was automating with actions after we took a look at Dependabot and managing those dependencies. And then finally we looked at GitHub Advanced Security and how we can use code scanning and the secret scanning capabilities as well. So with that, what should you try next? Firstly, if you haven't got a GitHub account, please sign up. Get started with your open source journey. It's a great way to learn. It's a great way to develop your own expertise and somewhere to store your pet projects. If you're using those projects, maybe you want to try code spaces, GitHub Actions, or manage your dependencies with Dependabot, or even do that internally within your organization as well. Again, a reminder to sign up, and I would love to hear your questions here today. So looking forward to chatting further. Thank you.